Hi, everyone. My name is Jeffrey Tang, a senior application scientist of Axon Electrophysiology and Molecular Devices. Welcome to watch our Axon Tech Tip video in the newsletter of this month. In this video, I would like to show you one of the useful features in Clampex. That is called scope trigger. So in the past, I have been helping a lot of customers to create protocols for their experiment. One of the frequently asked protocol is illustrated in this slide. For example, in this slide, I want to make a continued recording. And when the acquired signals reach a threshold, then I want to send a TTL voltage to trigger an external devices. For example, in this case, it's an external stimulator, which send an electrical stimulation to the recording cell. So that is the protocol that customer want to create. Now, where do you find the scope trigger? Now, it can be found in the trigger tab of the edit protocol in the Clampex. It's showed here, trigger tab. And then if you check this trigger tab, you will see the scope trigger. Now you need to select this scope trigger checkboxes. And of course, you also need to set the trigger settings, including the pre-trigger length or in trigger threshold. And on the front panel of the digit data, for example, 1440 or 1550 series. And this is slide just show you the 1550B. And then you also need to connect the scope to the external device. Then after you make the connection, now this is what the scope trigger work. Now, first you can see that there's a long continuous recording, and you set the threshold voltage, for example, in this case. Now, when the signal is reached to this point, threshold, and then the scope BNC port from the 1550B will send a TTL pulse to the stimulator. Now, I'm going to do the demonstration, but I want to use this slide to show you the setup in my demonstration. In this slide, just show you the Clampex. You create a protocol. The scope trigger can be a variable embedded in like gap-free, or in this case, I use high-speed oscilloscope. You need to set this kind of setting. And on the trigger tab, you select the scope trigger. And at this time, I set the pre-trigger length with 2 milliseconds, and the pre-trigger threshold is 2 volt. And at the left bench, I also changed the unit in volt, and the scale factor is 1, both in the channel 0 and the channel 1. Now, on the digit data, on the front panel, I make it use a BNC cable, connect the digital output channel 0 to analog input channel 0. Now, I would like to use, because I don't have I don't have the recording cell here, living cell here. I would like to use this digital output TTL pulse as a acquired signal. All right. And then I also have another BNC cable connect the scope to the analog input channel 1. So this one I can monitor. I can see the TTL signal from the scope trigger. This is why how I can monitor using channel 0, monitor the acquired signal, and this one, channel 1, to monitor for the TTL pulse from the scope. All right, let's do the demonstration. Now this is a Clampex. I use a P-Clamp 11.2. Now let me check. Go to edit protocol. Show here. Then I use high speed oscilloscope. And it said 10 seconds here. And the input, I just check channel 0 and channel 1. Remember that channel 0, I can monitor for the acquired signal. That is the digital TTL pulse. And the channel 1 is the TTL pulse from the scope. And then the trigger, I use check the scope trigger checkbox. I set the threshold is the 2 volt. All right, and that is the for the edit protocol. Now for the lab bench, I set in voltage, it's a unit for the input channel 0, and the scale factor is 1, the same for the input channel 1, 2. All right. So let's run the protocol, and then I will use this digital output. I will check these boxes as acquired signal, and then you will see that the scope trigger will be also we send the TTL pulse out. Now let me just run it. I click here. Right. I click here. You can see it's running. Okay. After 10 seconds, it will run. And then after it run, and I will check these boxes. I will run. I check it. You see, when I check it, I stop this one. So when I check the TTL pulse, you will see the signal will, because the 5 volt, 4 to 5 volt, will across this, will reach this threshold point, and it will trigger, the scope trigger will happen, so that the TTL pulse will be sent out from the scope BNC port. Now, what happened is that if I increase the trigger, the threshold, as like, 6 volt, for example. Now you can see the light is here. Now if I run it again, when I run it, it started about 10 seconds. Okay, almost there. So it start to run, and then when I click this one, I stop this. Now you can see when I click the digital output channel 0. Now even though I have the 4.5 TTL pulse coming out, but it's not reaching to the threshold. So that's why you don't see the TTL pulse from the scope in here, right? Now, and also, now let me show you another one. So right now, when I bring it back to 2, I can run this one in the gap free mode. In order for you to see, I want to change the scale like this. All right, now for the gap free, unfortunately, we don't see the threshold point, the threshold line, assuming that is a 2 volt is here. Now we're going to run it. Let me uncheck this one first. Now when I run it, okay, now then I click this one. I stop it. You can see now this also working in the gap-free mode too. When I check, you will see the TTL pulse from digital output channel 0, and then because it crossed the threshold is the 2 volt, you can see this is the TTL pulse from the scope, BNC port. Anyway, I hope that I successfully demonstrate you how this scope trigger work. I hope that you enjoy it, and thank you for your attention. Thank you so much, and see you next time.